Hello guys, let's solve the question number of smooth descent periods of a stock. So let's see what this question says. So basically you are given an integer array prices representing the daily price history of a stock. So let's say you have days start from let's say 0, 1, 2, 3, and for each day you will have some price. Like it can be like, if you consider this, it is like 3, 2, 1, 4, so on, like this. And a smooth descent period of a stock consists of one or more contiguous days such that the price on each day is lower than the price on the preceding day by exactly one. What does this mean? So let's say one or more contiguous days. That means this and this, 3 and 2 are contiguous, 2 and 1, like this. So it should have, like, each day is lower than the price on preceding day. So for 2 we can check with the previous day, that is 3, it should be lesser, and that too exactly by 1, that is 2 minus 3 minus 2 is 1. So this is a valid smooth descent period. So if you consider again 1, 2 minus 1 is again 1. So this entire thing is a valid smooth descent period. So let's understand this with a larger example. So at last we need to return the number of smooth descent periods. So yeah, if we have, like, let's say 1, 2, and then maybe 5, 4, 3, 2, 1. So to visualize this, let me draw a graph for this. Let's say we have, like, first point is 1, then we have 2, 1, 2, then maybe 5, then afterwards 4, 3, 2, 1, 4, 3. Let me write the numbers: 4, 3, 2, 1. So how do we count the number of smooth descents? Okay, first let's calculate, like, manually how we do. So let's start with the first one, 1, and before that nothing is there, so this can be a valid one. So I'll write it here. Let me write it here only. So I'll write 1, then I'll go to next one, 2. So previous one is 1. Is it a valid one? No, because it is increasing. So the previous day should be greater and the difference should be 1. So but here the 1 is smaller, so it is in increasing. So it is not a valid one. But only 2, yeah, it is also a valid one. We can just consider only 2. Now let's go to 5. So same here, it is increasing, so it is also not valid. Only 5 can we consider? Yeah, we can consider only 5. And next is 4, 5 and 4, and it is decreasing. Difference is 1, so it can be also 1, 5, 4. And next we can go to 3. 4 minus 3 is 1, and it is decreasing. This can also be 1, 4, 3. Same for 3, 2, and last for 2, 1. And if you see this entire thing, how many we can form actually? Let's see. So you have 5, 4, 3, 2, 1. There are different things we can form, not only these, like 5, 4, 4, 3, 3, 2. Not only this, we can form 5, 4, 3, 2, 1, 3, 2, 1, 4, 3, 2, 1, like this. These are also valid descents. So let's see how we can calculate. So this entire thing is also a valid one. How do we calculate this? So let's start with the 5. Okay, so we'll start from the 5. So can we do 5, 4, 3, 2, 1? Is this the valid one? Yeah, because 4 is lesser than 5, 3 is lesser than 4, 2 is lesser than 3, 1 is lesser than 2, and all the difference is also 1 here. Yeah, we can do this. So again, what else? If we not consider 1, that will become 5, 4, 3, 2. This is also a valid one. So what else? 5, 4, 3, 5, 4, and then 5. So these are the valid ones if we consider 5 here. So how many we can form? 1, 2, 3, 4, 5. From here we can form 5. Now let's exclude 5 and start with 4. How many you can form? I'll write here. 4, 3, 2, 1. This is the one we can form. Same here. 4, 4, 3, 2, 1. Difference is 1 and it's decreasing. A valid one. Next, let's exclude 1 here. So it will become 4, 3, 2. Next, we can exclude 2. It will become 4, 3. Then 4. How many are there? 1, 2, 3, 4. From here to here, we can have 4 more. Now, let's exclude 5 and 4 and start with 3. So we'll have 3, 2, 1. Then we can have, if we remove 1, it will become 3, 2. Then we'll have 3. So this is the count is here 3. Same for 2. Let's do 2, 1 and 2. We can form 2 here. And at last for 1, it is 1. So we'll have for this range 5, 4, 3, 2, 1. How many valid descents we can form? That is 5 plus 4 plus 3 plus 2 plus 1. So what is this 5 plus 4 plus 3 plus 2 plus 1? I'll write it here. 5 plus 4 plus 3 plus 2 plus 1. So this is basically 1 plus 2 plus 3 plus 4 plus 5. If we take n here, this is the sum of first n natural numbers. So if you don't know the formula on how we can calculate this fastly without like iterating and calculating the sum. So sum of first n natural number is nothing but n into n plus 1 by 2. This is the formula. So manually if you calculate it will become 3, 3 plus 3 is 6, 10 and 15, right? So we can apply the formula directly. So n is here 5. 5 into 6 by 2. That is 6 5 is a 30, 30 by 2 is 50. So it's the same. So we can use this formula and calculate it fastly. So now let's go and like try how we can calculate the descents, like how we can in our code we can implement this descent. So imagine you have something like same example. If I take like 1 5, then let's take it 5 here, maybe 4 3 2 1, and after that you have like maybe 10. And also one more thing to tell, imagine you have something like 10, after that 8. This is not a valid descent because it is decreasing, but the difference is here 2. But in question they have clearly mentioned the difference should be 1. So this is not a valid one. So if you have something like 7, maybe 6, this can be a valid one. How we can calculate this parts, like find out 5 4 3 2 1 these blocks and 8 7 6 these blocks. Let's see. So we can start iterating from the first one. So when you have only one point, the count will be 1 here. So I'll consider the first point because there is nothing before this, no? So we'll set the count as 1 and start from the second point because uh, we need something to compare with the previous day, right? So 5. 5 and the previous one is 1. So 5 and 1. So 5 is basically greater, so it is increasing. So it's not a valid case. So the previous descent was having only one point, that is 1. So for that we can apply the formula. Now of course we have only one point, the answer will be 1. So even if we apply the sum of n natural numbers formula, it will be same. 1 into 2 by 2, that is just 1. So our current answer is 1 now. Now we move to the next point, that is 5 we were in. So again we set the count as 1, move to the next one, and 4 we compare with the previous one. So previous one was 5 and it is decreasing, difference is 1. So now we will not apply the formula and calculate it because it is decreasing. So we increment the count to 2, move to the next one. Now we are at 3 again. Now it is decreasing, difference is 1. We increment the count to 3, now go to 2. It is also a valid descent, so we'll we'll make it, sorry, we'll make it 4. Then we'll move to the next one. 1 2 minus 1 1, difference. So this is also a valid one, we got 5. So now we move to the next one, that is 10. Now it is not a valid descent because it is increasing, difference is also not, yeah, that's why the 5 won't increase to 6 here because it has broken the valid descent. Now we need to calculate the answer for the this descent, right? And set the count as 1 afterwards. So first we do is calculate for the descent and set, we can say reset count to 1. Now for this 5, 5, 4, 3, 2, 1, we have n equals to 5. Apply the formula n into n plus 1 by 2. That is, we'll get it as 15. We add 15 to our answer. So our answer is, so previously our answer was 1 here for this point. And now we got 15. So answer is now 16. So now go to 10. Now we go next 8. But it is decreasing, but difference is 2. So it's not a valid descent. Now we calculate the answer again. For 1, it is just answer is 1. So we update it to 17 and set the count as 1 here again. Now we move to 7. For 7, difference is 1. So and it's decreasing. We reset the count to 2. Now we go to 6, increase the count to 3. Now we have nothing. We have finished the entire given array. So after this, after we do everything, we can just again count for this part. So our current count was 3, right? So for this answer will be 3 into 4 by 2. That is 6. So for this we can form 6 valid. Yeah. So answer will be now 17 plus 6. That is 23. So how we can code this? Let's see. Let's see. Let me. Okay. Yeah. So let's start coding the solution. Let me zoom the screen. Let me. Yeah. So we take n for the size of array. Then what we can do is we need to set the current count as current descent as 1. So I'll declare one variable current descent, that is I'll set it as 1. Let me the return type is long here, so let's better make this long so it will be easier to multiply, and our answer is currently 0. So as I told you before, we'll start from the I equals to 1 because we need something to compare with the previous day. So I plus plus, so we loop till last, and uh, when we need to increase the current descent and when we need to reset it back to 1, that I have explained in the explanation. So basically, if it's a valid descent, for that to happen, so previous preceding day and the current day, it should be decreasing and the difference should be 1. So the previous day will be, let's write it here. Okay, I'll the previous day will be prices of I minus 1. That is the previous day. That should be greater, let's say that will be greater than the current day, and the difference is 1. So prices of I minus 1 and prices of I should be equals to 1. Then we increment the current descent, that is plus plus. Else it has broken the valid descent which was happening before. So we reset it back to 1. But before that, we need to calculate the how many valid smooth descent periods we can form for the previous current descent which we had, and add it to the answer. Then after that, we reset it back to 1. So for that to do, we just add answer with n into n plus 1 by 2. So n is nothing but the current descent which we had. That is current descent into current DSC plus 1, n into n plus 1 by 2. This. Yeah. And after this, we reset current DSC to 1. So this will do the job, and we need to return the answer, right? So before that, after we do everything, we need to add this thing again, because I'll explain you why. Because see here, in the previous example, as I told you before, imagine you have 5, 4, 3, 2, 1. As the last, as I explained the last test case, we had 5, 4, 3, 2, 1 at the last. So this statement will never be executed in that case, 5, 4, 3, 2, 1, because it will count like, imagine you are at 5. Let's say I'll write it here. 5, 4, 3, 2, 1. So we'll start from 4, right? Our current descent was 1. So now it will become 2. Here it will go 3, 4, and 5. This statement will never be executed. So once it comes out, and we need to calculate the current descent and add it to the answer, right? So if we don't add this, the answer will be, for this test case, it will return it as 0, but it should be 15. So for that to happen, we execute this statement. Once we do this, we can just return the answer. So let me run and check. Yeah, it's passing. Let's submit. Yeah, uh, that's it for today's video, guys. If you like the solution and explanation, just hit the subscribe button. Thank you.